Hello friends, now let us apply first law of thermodynamics to the constant pressure process. Now this is the PV diagram for a constant pressure process, state 1 to state 2. This is the PV plane and we are represent state 1 to state 2 represent constant pressure process. Now as we know, area below the curve represents work done for a particular system. So W is given by integration of P dV. So this area, entirely this area represents work done by the system. Now this is our first law of thermodynamics. Now let us apply pressure volume temperature relationship for the state 1 to state 2. Therefore P1 V1 by T1 is equal to P2 V2 by T2. So this is a pressure remains constant, P is equal to constant. So this equation becomes V1 by T1 is equal to V2 by T2. So as we know, W is given by integration of P dV. P is constant, it is outside the integral sign. So P dV, W is equal to P in bracket V2 minus V1 is the work done in a constant pressure process. W and the unit is kilojoule. Similarly, delta U, let us calculate change in internal energy. Change in internal energy mCV T2 minus T1 kilojoule for m is equal to 1 kg. So delta U becomes, so this is 1 kg, we can replace delta is equal to m into Cv. For m is equal to 1 kg, this equation becomes Cv into T2 minus T1 kilojoule. Similarly, delta Q, work done, heat transfer in a constant pressure process. Delta Q is equal to m Cp delta T, and finally this can be calculated by this equation m Cp T2 minus T1 kilojoule. So in this way we will apply the first law of thermodynamics to the constant temperature process, entropy process, constant entropy process and polytropic process. Now in coming videos we will see how we can apply the first law of thermodynamics to the constant temperature process.